Welcome to Introduction to Accreditation Part 3, where we discuss the IME Department's approach to meeting ABET requirements for assessment and continuous improvement. The IME Department has been knee-deep in assessment ever since the requirements were changed. In fact, we were a little bit involved with it before that, but back in 1999, our ABET visit allowed us to use the 2000 criteria in lieu of the previous criteria, which was based on outcomes assessment. So we did that. As part of that, we got a grant from the Society of Manufacturing Engineers that allowed us to hire a facilitator and lead us through the use of quality function deployment to connect with our stakeholders and develop our mission and vision statement, outcomes, and assessment methods. And then what we've been doing ever since then is tweaking that and making adjustments as necessary. The 2005-2011 ABET self-studies were very data-driven. We gathered enormous amounts of data, more than we needed, and actually we went so far overboard for 2011 that we dialed it back quite a bit and made some much needed improvements. And I feel very good about the data we've been collecting the last 6 years. What we haven't done adequately is to analyze all the data. We have been doing that, but we could have been doing it a little more thorough. Here you see a scary looking flowchart of our assessment process, our system. Those three large boxes in the middle are basically showing our three areas of outcomes assessment. Our outcomes, or PEOs, are at the top, program objectives, and that box shows how they were developed and what we came up with. The middle box are our student outcomes. It shows how they were developed and deployed. And the bottom one refers to, at the course level, we have course outcomes, and those are explained on each of the expanded course outlines. I'm not going to discuss each of those middle boxes here because they get discussed elsewhere. But on the left, we showed the boxes on the left show how we iteratively use various sources of information and validation. And then on the right, we show the assessment and feedback loops. So it's an impressive flowchart, if I do say so myself, but we'll move on. Here we have the IME Department mission statement. The first one, to serve the university, the community, and our alumni by offering ABET accredited degree programs and courses that prepare students for study at both the undergraduate and the graduate level. Number 2, to teach sound engineering principles, ethics, and theory, supported with significant classroom, laboratory, and industrial experiences to a diverse student population. Our goal is to prepare students for immediate and productive entry into today's workplace or the best graduate schools. The third one, to continuously improve the curriculum, faculty, scheduling, advising, teaching methods, facilities, and student services while maintaining safety of students, faculty, and staff as a top priority. And finally, to educate the general public about the exciting fields of industrial and manufacturing engineering and the opportunities available at Cal Poly Pomona. We have tweaked this over the years. We have reviewed it about every 2 to 3 years with our Industrial Advisory Council. Our IME 460 students critique this once a year when I teach 460. And so we have some feedback. We have tweaked a few things. Like I said, the most controversial item is probably the last one, about to what extent are we active in going out and promoting industrial and manufacturing engineering. But anyway, this is our current mission statement. Next, we have our program educational objectives. Again, let me say that these are routinely reviewed, and not much change has occurred because our Industrial Advisory Council and others have found these to be fairly acceptable over time. But the wording has been questioned a few times. For example, the first one, enjoy successful careers in industry, research, or academia. The question is, okay, what does enjoy mean? But moving on, number 2, continue to pursue knowledge and professional growth. 3, perform leadership roles by enhancing collaboration between engineers, scientists, professionals, and business people. 4, contribute as professionally, ethically, and globally aware members of society. Now, the first 4 are common between industrial and manufacturing engineering. Numbers 5 and 6 vary between the two disciplines. Although they are very similar, you can see the subtle differences. Number 5 for IE, engage in design and integration of production, quality management, and information systems to provide optimal solutions. That covers a wide range of what makes industrial engineering unique and the systems approach. And then number 6, understand and influence the physical aspects of their business or company, which is very important for industrial engineers and is not mentioned specifically in the ABET A through K criteria. Here we have the manufacturing engineering PEOs. The first 4 are the same. Number 5 is engage in the design and integration of materials transformation and production processes. And 6, positively impact the physical performance of manufacturing enterprises. Now we get to the IME department's student outcomes, and you can see that we have A through K, but here we have our definitions of what those are, which are based on the intent of the ABET A through K definitions. But what ours show are 2-sentence definitions where the first sentence kind of describes what our lower division courses would be contributing to the outcome in terms of introductory material and getting basic knowledge. And then the second sentence usually refers to the development of skills and abilities and an experience in applying the material. And so you'll see these 2-sentence, 2-level definitions that we show here. Sometimes we separate the 2 sentences when it serves our purposes, and other times we just leave them lumped together. So the second one, design experiments, the ability to design and conduct an experiment, ability to interpret statistical quantitative information, and apply experimental results to improve a system or process. Now let me say that for us, design experiments means design of experiments, a specific approach to using designed experiments. However, I've asked members of the ABET board if that's what it means for everybody, and they've told me no. Design experiments from the ABET general context does not mean design of experiments. They knew exactly what I was asking. And most programs don't teach design of experiments, but they teach experimentation. Whether it follows classical design of experiments or not, probably not. System design, interdisciplinary teamwork, and problem solving. Let me comment on interdisciplinary teamwork. The one of the issues is, what does interdisciplinary mean? And in our case, if we wanted to uh, be strict about it, we can make sure there was an industrial or manufacturing engineer in each team. Or if we wanted to broaden interdisciplinary, how could we incorporate other disciplines outside of ours, either other engineering disciplines or other colleges? So this has always been problematic, and I think in the new criteria they've taken out that word interdisciplinary because of all the problems in dealing with it. If we were forced to prove evidence of interdisciplinary teamwork, then we would have to make sure that we have a sample of projects or courses where we do have interdisciplinary work in some way, shape, or form. F is professionalism and ethics. We get a lot of benefit from our IME 402 course in this field, but basically ethics is taught throughout the curriculum, or should be. Communication skills has to do with all forms of communication, written communication, graphical communication, making oral presentations, different types of written material, not just senior project reports, but memos, lab reports, proposals. Those all fall under the area of communications, and it's been probably one of the areas that industry has pointed out to us is one of our areas we need to improve on. H, global and societal impact. That outcome is difficult to assess using some of our surveys, so we have come up with a way of doing that that will be explained in a few slides. I is lifelong learning. The problem with assessing this is that how do you assess if somebody understands lifelong learning if they haven't even graduated yet? So we have to have some kind of discussions about lifelong learning throughout the program, whether in class or using guest speakers or other professional opportunities, and somehow assess if our students have figured it out and have the ability to do that. Contemporary issues is shown here, and it is a difficult one to assess as well. And so I'll show you how we do that on a future slide. Engineering skills and tools, knowledge and ability to choose the proper tools and for design and problem solving, and then effective use of software and other tools to design and solve problems. So we have to demonstrate this. I think that this has changed a bit in the proposed criteria, but somehow our students need to be able to have skills in using software and other tools. Then business skills has to do with understanding the profit aspects of a company and decision making for proper use of capital. And finally, we added employability. This was based on our quality function deployment efforts many years ago, and we haven't seen any reason to remove this. But our students need to be able to have some sense of what they need to do to be prepared for employment upon graduation, which I think a lot of us hammer into them, and then they need to understand what a career path could look like. A common requirement for WASC and for ABET is to have what has come to be known as a curriculum map. And this is where we show for each of our student outcomes where in the program, which courses we cover that material, and the levels that we can cover it at are introductory level, where it's just introduced, the developmental level, where they get deeper knowledge about something and get practice in problem solving, and then finally at the mastery level, where they have an opportunity to apply what they've learned in an open-ended type of a context, whether it's a project or a case study or something. Then also added in here is where we do program level assessment using our program level assessment instruments, and that's what the A stands for. Now, course level assessment is shown on the expanded course outline, but not on this curriculum map, because otherwise we'd have way too much information on there. Now, this particular curriculum map needs to be updated. So if you see some things on it that you really question, that's because they should be questioned, and we need to always be updating it. Here is the manufacturing engineering curriculum map. Same comment that it needs some updating, but it'll always need updating. And then this is a guide to how, this is pretty much an overview of our assessment program, because those letters A could refer to any number of instruments depending on what it is. This is our Outcomes Assessment Instrument Matrix. This is very important when it comes to ABET. Our visitors really rely on this to know where to look for assessment. There are two matrices that I haven't included in any of these presentations. One is a mapping of our mission statement into our PEOs, and another one is a mapping of our PEOs into our student outcomes. But here we have a mapping of our student outcomes to the various assessment instruments we have. So each column represents an assessment instrument, and then in the subsequent slides we're going to take a look at each one of those instruments specifically for the purposes of educating you on what we're doing for assessment, and there'll be more detail. So here we're beginning to look in a little more detail at our assessment practices in the IME department. And what I've done is color-coded, I've shaded the boxes. Green means that we have current data and it's pretty much ready to be evaluated, and some of it has already been evaluated. But the green means we're good to go to use information. And then on subsequent slides, some of it's yellow, means that we've gathered some data. We still need to gather some more, and then interpret it. And finally, red or pink means that we've got some data. It needs to be input and evaluated. So explain those as we go along. So the first survey you see at the top, it's our alumni survey. It's sent by email to our alumni. We're supposed to do it every 3 years, and when I say supposed to, that's what we've said we will do. And we have administered it in 2013, and we recently administered it and got our data. And this is a survey with questions designed to find out how well our graduates have been achieving the program educational objectives. And we ask them to give a strongly agree, neither agree nor disagree, etc. response to the various questions. And we're hoping that they strongly agree or agree, and an average of 4.0 or higher is satisfactory for us, and that's what we're shooting for. And let me just add that samples of these survey questions as well as results of the surveys are in the IME department ABET assessment organization in Blackboard, and then any faculty member can go in there. It's only available to faculty in our department and others that have been invited in the college. And then you can see the results of these surveys so that we can begin to evaluate them or continue to evaluate them and see what we need to work on. And so they're not shown in the survey, but they're not shown in the PowerPoint, but they're available online in the Blackboard group. And so you can look at those depending on what your role is in doing that. Our course outcomes, the next survey shown here, as part of our senior exit survey, we asked them to assess their course outcomes for the courses shown in the middle box. So those are not all the courses in the program. They are a lot of the courses that are common as IME courses for both majors, but then there are some more specific ones that a student may not take if it's not in their major. But anyway, we ask the student to assess how well they can apply what they've learned in those courses, and then we also ask them for some comments about their courses. And you can see the criteria on the right. We want to get at least an average of 3 or higher in those in order to be minimally acceptable. But if we see trends that are downward, or if we see low scores, then we can say to ourselves, okay, we need to do something. Also on the senior exit survey, we asked the students to evaluate A through K plus L and M. And here we're looking at their ability to apply knowledge in those A through M areas. And again, we can look for trends and look to see where we have gaps to work on. And then that's ready to go for us to look at. The next one down, senior project presentation assessments. These are the industry assessments. We have all of the results from 2011 through 2016 from industry visitors where they've assessed the 10 different criteria on the rubric. But we still need to input that into a online survey and then summarize the results and then take a look. However, I will say that we have been reading the results at the end of every quarter when they've been turned in, and we've been discussing the results with our IEC members at IEC meetings, and we have been making changes. So we have been using the data, but we haven't been using it from a summarized format. So we need to do that very quickly. We also want to evaluate our students' written abilities by analyzing their senior project written report. So we have a rubric for that, and we try to take a 20% sample. And since we don't have one report per student, we have teams who have written reports, then a 20% sample is acceptable and takes time anyway. But we're looking for how professionally written the report is in those different areas on the rubric. The next item, senior project reflective piece. This is where we ask our students to write a 3-page reflective piece about items H, I, and J. And we've already assessed what we had up through 2015. We've received some more reflective pieces as of the last 2 quarters, but we haven't evaluated those yet. But we do have quite a bit of data, and it's good enough for us to do some more evaluation with to see how we're doing on these kind of qualitative issues. Another survey that's given is for the industry people that visit during the project symposium. They're sent an email with a survey and asked to assess 7 outcomes in 2 different ways. One, how important are those 7 areas to you? And secondly, what was the quality of what you saw? And then we make a gap analysis and rank the gaps from biggest to smallest. And every time we do it, the top 3 items that show up as the biggest gaps are communication skills, teamwork, and problem solving. So those 3 areas have been taken on by the whole college for improvement. We have data up through 2014. No data was gathered in 2015, so we need to collect it again in 2016. We collect the data for the whole College of Engineering, but it's sortable down to the department level. So we can see how, if we're making any progress based on this helicopter view of what our industry friends saw. The next one is the lower division knowledge exam. This is formative assessment where we want to see along the way, in the middle of the program, we want to see how much of our students really learned and retained from our lower division courses. So we examine them in 5 areas: engineering graphics, materials, processes, statistics, and work measurement. And the data from this test, it's a 50-question test, is given in IME 326. This test is given there, and we have the data collected and inputted up through the last, let's see, it would have been fall of 2015. And so that data is available for evaluation. 2 more surveys that are available. In IME 112, the students do a team project. They learn the high performance team model, and they go through a lot of self-assessment and team assessment. But at the end, I give an anonymous survey and ask them to answer some questions about their teamwork experience. So we have this data available to include in assessing the teamwork student outcome. And finally, a survey that we have, the IME Advising Survey. This survey hasn't been given in 6 years. We're going to give it right now this quarter. But it asks in great detail what students' attitudes and habits are with respect to study habits, time organization, study skills, their advising experience, use of advice from their advisor, and then any success they might have in the program. And we also gather a lot of demographics that allow us to do some analysis to see if we can identify relationships between different students' characteristics and then what their success is. So we need to give that again, but it's been a very fruitful survey in the past and in giving us some introspection into our students. And I believe that the next version, the 2016, is going to show us some marked differences in demographics with our students